Okay. Here's a hint for when you're doing the tests, is that if the question asks for a number or a probability, then you use norm dist. Okay, so there are two things we're learning today, norm dist and norm inv. And norm dist is if it gives you the numbers and it wants a probability or a proportion or a number of things as a result. If it has instead a level of probability, then you want, and it's asking for a cut-off point or something like that, then you want to use norm inv. So here's an example. So often in production areas we want to decide on the level of probability and need to find the cut-off point that corresponds to it. So coming back to the paint cans, we may decide that it is okay for 5% of our cans to be over a certain... No, that's not how I would do it. You want to know what is it that 5% of our cans will be fuller than. Okay, and this one, a number of people in emergency waiting room at peak times is approximately normal distribution. That's not very well put. I should say is well approximated by a normal distribution, with a mean of 22 and a standard deviation of 7.3. The hospital wishes to provide enough chairs so that 95% of the time, at peak time, everyone has a chair. How many chairs should they provide? Now this is one of the most important things you can learn, I'm hoping, from this course. Can you guys stop talking? Okay. Is that don't ever supply to the mean. And this is one of the big mistakes that people have made, and often in disastrous results. Now, an example I can tell you about, I've forgotten which airport it was, but there was an airport where they built a hangar in order to fix aeroplanes in, or to store aeroplanes or whatever, and they built it so the average number, like they knew the average number of planes that would need to be stored, and they actually built it for that size, for the average number. Okay, so how often would they have too many planes? About half of the time. Okay, if you supply to the mean, that means that half of the time you haven't got enough. So you never supply to the mean. It's sort of like if this is the only thing you learn from this course, is that you don't supply to the mean, or you don't build resources to the mean, or whatever, that would be a good idea. Okay, so having said that, we don't want 22 chairs. Okay? If we have 22 chairs, that means that half of the time there will be enough chairs, but only half of the time. That means half of the time there won't be enough chairs. And so you don't want that. You don't want a level of service of halfway. You don't want half of the time people get dissatisfied. You don't want to run out of Kentucky Fried Chicken half of the time. You need to know where your service level is. And one of the problems too is that not only do people get stuck with serving the mean, and you think of fire engines, would you like your fire engine to turn up at your place before it burns down half of the time? Okay, well that's not very good, because if you happen to be in the half where it burns down, you can't do that. But at the same time, you cannot set up a system whereby the fire engine, say they've got a 7-minute response time, and you want your fire engine at the fire within 7 minutes. And if you want to make it every single person in Christchurch, a fire engine will make it to their place within 7 minutes of a call. What's the problem with that? Why can't it happen? Can it happen? How could it happen? How could you make it so that no matter where in Christchurch there was a fire engine will always turn up within 7 minutes of the call? How could you do that? Yeah, pretty much. Yeah, lots and lots and lots of fire stations, each with lots of fire engines, just in case there are 2 fires simultaneously in adjacent houses or something like that. So the cost is immense. And this is the problem with government and with people, is that basically they see the individual and they say, I live in Fiordland, I want to be able to get to my hospital within 2 hours or something like that. But the problem is that in order to provide that level of service, the cost is absolutely prohibitive. And so we can't make sure there's always enough chairs, because that would be silly. We would have so much waste capacity and we would be wasting money. And so it comes back to the old thing, is that occasionally KFC should run out of chicken. Okay, so it's not going to be 22. How much do you think it should be? Is it going to be more than 22 or less than 22? It's going to be more than 22. Now this may sound like a silly thing, of course it's going to be more than 22, but there are some questions in the Proctor quiz that throw people, because it talks about being fast in a race and slow in a race, and in fact when you're talking about times, little means fast and big means slow, and so you have to think ahead of time approximately what sort of number am I talking about. Okay, it should be more than 22. Right, so what we do is we use the inverse normal. So basically, how it works, I'll come back to here, sorry, is it finds where is the place in here where that has 5% there, or the other way of looking at it is that this bit here is 95%. Okay, my shading's not very accurate. I was never good at colouring in. Okay, so we want to have a number here, and you see sometimes if it's given as 5% more or 95% less, sometimes it's confusing as to which number you use. So that's why you should always have an idea in your head, is it going to be more than the mean or less than the mean, so that if the answer looks silly, you know it's silly.